Okay, let's implement this function together. First of all, we need to create target. However, creating target is quite easy because we just need to sample corpus from window to minus window size. I explained that when the window size is 2, then 3 cannot be the target because we cannot have 2 contacts on the left side. Therefore, the target starts from 7. And this is after the window size 2. Okay, so we can simply retrieve elements from at the position window up to minus window. And that's target. Quite easy. And contacts, we just create an empty list. And therefore IDX in range window size, then corpus minus window size. And then we sample context. So what we're going to do is from this IDX, we're going to vary T. So T ranges from minus window to window plus 1. And we are adding that T to IDX. Therefore, this IDX is actually the index of a target. So when we start from here, if the window size is minus 2, then we subtract 2 from IDX and then goes to here. And when T equals 0, that means the current value is target. So we need to just continue. That's why we are putting continue here. Okay. And after this iteration, we append context like this, and we just return context and target as empty array. Okay, another utility function we need is convert one hot. Given corpus and vocab size, what we're going to do is convert all of them into one hot vectors. We first need to check the size of the corpus. If the corpus dimension is 1, that means we just need to create empty zeros as n vocab size like this. And data type is integer. And for IDX and word ID, enumerate corpus, we just put 1 at the position of word ID. And at other positions, we just put 0. Like this. And else if corpus and dim equals 2, that means it contains batches of corpus. Then what we are going to do is retrieve the shape of the first dimension. And one hot vector would look like n c vocab size like this. And the data type is the same as integer 32. For IDX 0, word IDs, for IDX 1 and word ID. IDX 0, IDX 1, word ID equals 1. Then we just return 1 like this. Okay. So these are utility functions we need for implementing cbow and skipgram. Okay. First of all, let's implement naive or simple skipgram and cbow. We are going to talk about more advanced cbow and skipgram in the later of this session, so don't worry. The first one is simple cbow. We of course need the initializer. This one receives vocab size and hidden size. And when we are implementing this simple cbow, we are going to assume that we'll just use the window size of 1, okay? However, in the later version of cbow, it will receive the dimension or the size of a window, okay? And the next thing we need to implement is forward. This one receives context and target. Okay. And we will also need to implement the backward function, backward method, actually. Okay, let's implement initializer first. This one is vocab size and hidden size. And we first need to make weight. And W in weight converts cbow receives context, and then from context, it predicts target. So W in will convert context into word vectors. So it receives vocabularies as one hot vector. And W out receives converted context and predict. This one should be V and this one should be H, like this, okay? And predicts the target. All right, and we need to create layers. Here we're going to use matmul, matrix multiplication. And our layer is going to be initialized with W out. And here we're going to use loss of softmax. The improved version of cbow will use binary logistic regression. However, here, because this is a naive implementation, we're going to just use softmax loss. And we're going to collect parameters and gradients. An out layer like this. I told you that for unified implementation, we're going to store parameters and gradients in separate lists. That's why we're doing this job for all the layers. We did this for matmul as well. You remember, right? For layer in layers. So in this way, we can collect parameters from other layers. Okay, like this. And our W in is the word vectors we can use for external users. Okay, the forward pass looks like this. We first need to convert the left context into a embedding. And we're going to do the same for the context of from the right side, like this. And rather than creating two paths, what we are going to do is add H0 and H1 and just take the average. Okay? And the score is simply out layer, forward, H. The loss is going to be loss layer, forward, score, and target. And this score predicts the scores for each word, and it has the size of vocab. So it's outputting all the scores for each word. And by comparing target and the score, we can calculate the loss. Okay, for backward, looking at this forward implementation, think about how you can implement this backward method.